It's rare that you have to concern yourself with how variables are represented as bits, but if you're interested, keep watching. So 2's complement is the most common way to represent integers, and it's best illustrated with an example. Let's start counting up from 0 in binary, and then let's represent that. We're going to count up a byte, and let's represent that as a signed char in base 10 and an unsigned char. So we start out with 0, 1, 2, 3, 4, 5, 6, 7, 8. And the value of that for a signed and an unsigned char is 0. As we count up from there, then these last digits become 0, 0, 1, value 1, value 1, 0, 1, 0, 2, 2, 0, 1, 1, 3, 3, and so on, until we get down to 0 and 7 ones. 1, 2, 3, 4, 5, 6, 7. Where the value now will be 127 and 127, because we've got 164 plus a 32 plus a 16, etc. And now when we go count one more up, this bit here will change to 1. All the rest of them will change to zeros. And now the signed char changes to a value of minus 128. And unsigned, because it's always positive values, becomes 128. Then we have 1, 1, 2, 3, 4, 5, 6, 1. And that still continues counting upward after this flip. So now we're at minus 127. This is at 129. And we continue until we get to all ones, at which point this will have value minus 1. This is value 255, the maximum value. And if we add one more to that, we're going to overflow, go back to the top here, and minus 1 becomes 0, etc. Okay. So in 2's complement, this first bit here tells us whether we have a negative number or a positive number. And whether it's a char or an int or a long int, any integer type, when we have this transition from 0 to 1 in the most significant bit, then we have a jump from the maximum positive value to the maximum negative value. And that's the 2's complement representation of integers. Now, we can still ask the question, if I have an int, then that means I have 4 bytes. And if this is my memory map, then these 4 bytes might be sitting here. And I could ask, well, is this byte in the lowest address correspond to the least significant byte of the 4-byte representation? Or is it the most significant byte? And this choice is different for different implementations of C. If we choose this choice, then it's called a little endian representation. And this is what's used on the PIC32. And if we choose this one, this is called a big endian representation. Now if we want to talk about how to represent floating point numbers, the way they're usually represented, and here now I'm going to write out the 32 bits of a float, for example. This 32 bits get partitioned into one sign bit. I'll call that S. Then there are n bits for C, which I'll explain in a second. And then there are m bits for B. And these fit into the formula minus 1 to the S times B times 2 to the C. And B takes a value in the range greater than or equal to 1 and less than 2. So we're going to get m bits to represent a value between 1 and 2. And then we're going to multiply it by something that is 2 raised to the exponent c, where we have n bits to represent that exponent. So for a floating point number, we've got m equals 23 bits to represent b, and we've got n is equal to 8 bits to represent the exponent c. So 23 plus 8 is 31 bits, and the last bit is our sign bit.